Welcome to an example on finding the domain of various kinds of functions. So let's be clear what domain is. Domain is allowable x values. So which x values are allowed and which are not. So it's kind of like, say you have a microwave oven. There are certain things you're not allowed to put in a microwave oven, like tin foil or anything with metal, right? That would not be in the domain of a microwave oven. So a domain is allowable x values or allowable inputs, right? The x value is what you're plugging in, just like tin foil cannot be plugged into a microwave oven. Certain x values are not allowed to be plugged into certain functions. Now you might wonder, well, why not? Why can't we plug in? That's a great question, and let's jump down to, let's do the third, let's do them backwards. Let's start with this one. What is not allowed to be plugged in to that function? You might think, well, you plug anything you want in. Well, actually, no. Do you know that the denominator cannot be 0? That's one of the two things we look at. We say denominator, so whenever we do domain, we say denominators cannot equal 0. There's, in fact, yeah, let me back up and try to be more clear with what I'm doing here. Here's how we handle domain in general. Number one, if we have any denominators, we say denominators, you cannot equal 0. Why not? Well, because dividing by 0 is undefined. It's infinity. Do you know that? If you take your calculator and you take 3 divided by 0, you'll get an error because it's really infinity and the calculator can't tell you a number. Why is it infinity? Well, think about it. What is like 10 divided by 2? You know the answer is 5, right? Because 2 goes into 10 5 times. That's what a fraction means. It means divide bottom into top. That you know. We'll think the same way with this one. How many times does 0 go into 3? It goes into 3 forever. Infinity. That's why it's an error. Whereas if you have it on the top, like 0 over 5, that's just 0. 5 goes into 0 0 times. So 0 in the top is fine. We have no problem with that. That just comes out 0, right? You go into 0 0 times. But 0 itself will go into any normal number and an infinite amount of times. So that's why it's an error, and we don't allow it. So that's why the denominator cannot be 0. So we take this denominator and we say, all right, denominator, you're not equal to 0. So we actually solve the equation. It's kind of weird to have a not equals equation, but that's what we have. Now we solve for x. So let's add 1 to both sides. And this cancels. And we get 7x not equal to 1, and then last step, divide both sides by 7. Boom, x is not equal to 1/7. So x is not allowed to be 1/7. Any other number, fine. Do you see the problem? You see if you plugged in 1/7 right there for x, what is 7 times 1/7? What is 7 times 1/7? These would cancel, it'd be 1 minus 1 would be 0. See, that would make the bottom of that fraction 0, which is an error. You can't make the bottom of a fraction 0. It's infinity. It's not defined to be a number. So we cannot let x be 1/7. Any other number is fine. You can plug in any other number in the world that you want to, but you may not plug in x equals 1/7. That's not allowed. That's not in the domain. Like, can't put tinfoil into the microwave. So we say here, x, see how it already has the not equal for us? 1/7. X cannot be, the domain is x cannot be 1/7. It can be anything else, but it's not equal to 1/7. Okay, now there's one other thing we look for, and that is if we have a square root, then, and that's a 2 root, square. Square means 2, right? This is called x squared. Square is 2. So a 2 root, if you have a 2 root, then you take out the inside and you say, hey, inside, you have to be greater than or equal to 0, and then you solve. I'll just say dot, dot, dot. That's the other situation in which we have to watch out for them. Why? Why do we have to make that greater than or equal to 0? Because you can't have negative inside of a square root. Remember the square root of 9, of course, is 3, because 3 times 3 is 9. But what's the square root of negative 9? You can't do it. I'll just say no. It's imaginary, if you remember from earlier math classes. You can't, because what times itself is -9? There's nothing. Nothing times itself is -9, right? -3 times -3 would be +9. That wouldn't work. So anyway, you can't do it. So that's why we cannot have a negative in a root. Well, what does that have to do with this? We'll see what I'm saying here. Greater than or equal to 0. What does that mean? Positive or 0, right? Numbers greater than 0 are positive. So we're saying the inside has to be 0 or positive, greater than or equal to 0. It can be 0 itself. You can have a square root of 0. That's fine. That's just 0. Or you can have positive, greater than 0. But you can't have less than 0. That'd be negative, and that'd be imaginary. So we say if we have a square root, a 2 root, we say the inside has to be greater than or equal to 0. That's required in the domain. You're not allowed to plug in any other things that would make the inside negative. So those are the two things we look for in domain. Denominators cannot be 0, and the inside of a 2 root has to be greater than or equal to 0. For sure, put that in your notes for the next exam. Those are the two things we look for on a domain question. The denominator's not equal to 0. Notice I didn't even look up here at the numerator. I don't care about the numerator at all. It can do anything it wants to. It's not a problem for us. It's just the denominator that cannot be 0. Or if I did have a square root, a 2 root, I don't, but if I did, you will on some other problems, we say the inside cannot equal 0. I'm sorry, it has to be greater than or equal to 0 because it has to be positive or 0. It can't be negative. So then that brings us back now. I've been putting off questions 1 and 2 because they're so simple. Look at this right here. Does that have a denominator? No. Does it have a square root? No. Then it's got no problems. Its domain is -infinity to infinity. That's a way of saying all numbers are okay. You can plug anything you want. How about this one right here? Well, does he have a denominator? He has a denominator, but it doesn't have an x in it. So it's just 5. There's no way that 5 is going to be 0. There's no x. This x right here is not in the denominator. So we don't have any x's in the denominator. We don't have any way of making the denominator 0. And there's no square root. So he's also anything goes. All numbers. That's all numbers from -infinity to +infinity. Everything's okay for him as well. So when they don't have denominators and they don't have 2 roots, then their domain is -infinity to +infinity. It's all numbers are okay. There is no problem. The only problem areas are denominators can't be 0, and 2 roots, the inside, must be greater than or equal to 0. That is positive or 0, not negative. There we go.